Hey guys, my name is Joshua Lenahan. I'm currently a student at Alfred State College of Technology. I have an associate's degree in electrical construction and maintenance, and I'm currently working on my bachelor's in technology management. So I received a grant from Alfred State College to pay for the solar panels and battery for my tiny house, which I've been working on since the beginning of the semester as a independent study project. So since I began working on this trailer, I had the goal in mind of making it as environmentally friendly as possible, whether it be from spending $400 on styrofoam insulation to using an on-demand hot water heater so you can save propane, using all LED lights, and a 12-volt motor that will be run by solar panels. All these small decisions have made this a really sustainable project. And so this video is for those of you who might want to make your own project sustainable, whether it be a garage or a hunt-a cabin or your own trailer. This video is an instructional video of how to install your own solar panel system on a small off-grid scale. So to build your own solar panel system, you'll need a few key components. I have 200 watt Renogy solar panels. You're going to need a battery. You're going to need some conductors to hook everything together. These are my battery conductors, positive, negative, and my solar panel conductors, also positive and negative. And these plugs right here are going to take the solar panels and the battery from the outside into the inside, because on the inside I'm going to have my charge controller right here, which is pretty simple to hook up because there's nice little pictures here. You can see I'm going to have my positive and negative wires coming from the solar panel right here, battery in the center, and then my load, or my lights, will be, and my inverter will be going on my load output. Also, you're going to need some fuses. I'm going to be putting, this is a 30 amp charge controller, so I'll be hooking up a 30 amp fuse from the charge controller to the batteries. And then later I'll show you the formula. I'm going to have a 15 amp fuse for the solar panels to the charge controller. So I'm going to be building this project, building this system for my camper conversion project here. So, and then you can see on the side of this trailer, well, I'll be hooking up my batteries and my solar panels. The reason why you have this is like a 250 volt plug. The reason why I have these is so you can't plug a regular generator or 120 volt plug in there. That's actually a code to have a different kind of plug. And this is going to be for my generator right here. They're standard. The reason why I have everything outside is because I can adjust the solar panels to the true south and get the most electricity that I can. So let's start off here by showing you guys how to wire everything together. On the back of the solar panels, you'll see two wires coming out of each panel. Each one of these, there's a positive and negative coming out of each one, and then I'll be connecting the two positives together and the two negatives together, so I can just have two wires coming to the charge controller. And these are pretty neat little splice kits here Renogy makes. And so here's a basic diagram of the circuit. These will be connected in parallel. And if you don't understand what parallel is, pretty much means that both the positives will be connected together into one wire, and then both of the negatives will also be connected together into one wire, and both of those two wires will be hooked up into the charge controller. So let's get started with hooking up these plugs. Alright, so the fuse size for the charge controller to the battery just needs to be equal to the current rating of the charge controller. So in my case, my charge controller is 30 amps, so I would put the fuse on the positive wire going from the controller to the battery. For the solar panels, it's just a little bit more complicated, but it's not too bad. If in this example there's two 100-watt panels, and on each panel they have a nameplate, and you want to find the current of each panel, and then add up however many panels you have. In this example, there's two, and then multiply whatever that number is by 1.25, which is a safety rating that makes sure your fuses aren't blowing all the time. And then of course you're going to want to round up a little bit. In series, you just find the current for one panel and then multiply that by 1.25 and then round to the nearest fuse size. Alright guys, so the next step is connecting all the components together. Right now I've got this converter which takes 120 volts and turns it into 12 volts, and I'm just using that temporarily for my lights and stuff. But here's the charge controller. I've got that mounted on the wall. Underneath it you can see we have three pairs of wires. The battery, the load, that's the light bulb, and then the solar panels. So the two components that'll be outside are the battery and the solar panels. So I've got two pairs of wires and fuse holders on the positive wires, and that's going outside to my receptacle outlet. This is my solar panel and battery outlet box, and I have this special outlet. The bottom one's going to be for the battery, and the top one's going to be for the solar panels. And it's very important to break this tab so that the solar panels won't go straight to the battery. It's also very important that you make sure that the outlets, or the side of the outlets, match up. So if this is positive, then the outlet or plug should match that up, so you don't have the wrong polarity going to the charge controller. So right now I'm just going to hook up these solderless crimps and then hook it up to the outlet. Alright, so I've got this all hooked up. This is 10 gauge wire, and I'll have to make some labels on the side here that the bottom's going to be the battery and the top one's going to be the solar panels, because it's very important that you don't mix up the plugs. That's why I colored this one a little bit, but it's important to have proper identification for your plugs. So I'm just going to tuck these wires in there and finish capping off this outlet. The last step to installing your own solar panel system is making sure that your solar panels are oriented in a position that allows them to get the most amount of electricity. And so you're going to, three things you're going to have to be concerned about is, first, the amount of shade, second, the position of the solar panels, left or right, and then the angle of the solar panels, how high or how low they'll be facing. So, first thing regarding shade, they have a really cool tool that we used in school called the Solar Pathfinder, and this actually comes in with a glass bubble, and in the glass bubble you can see the amount of shade you'll be getting from trees, if there are trees around you, how that'll be affecting the amount of power you get. So you want to make sure there's hardly any shade, because that will greatly affect the amount of power you get. The second thing is the altitude of the solar panels, which is like the average sun's height, and you can find this online. Simple solar calculator. Again, this varies per location. So here in western New York, our latitude of the sun is 42 degrees. But to get the most energy from the sun, or the most amount of photons, is adjusting the module's angle, in the summer. So take away 15 degrees because the sun's higher. In the winter, when the sun doesn't get up as high, you're going to want to add 15 degrees, so the solar panels are a little steeper. So that'd be 57 degrees. And again, you're adding and subtracting 15 from the latitude, which is 42 degrees. The final thing is the azimuth, which is the sun's location east or west of the true south. So if you have a compass on your smartphone, you can set the setting to true south, right there. Okay, and then if you go to the compass, you're going to want to find the true south. which is right there. And then once you find the true south, you need to find your declination, which is the azimuth angle. Here in western New York, the declination is 11 degrees, so I would rotate the compass 11 degrees, and then that's where I would need to face my solar panels.